So here we are. I'm going to start talking about some questions. Now, these questions help us build sort of what we come to know as mathematical reasoning. So here are some statements 1 through 10. All natural numbers are integers. So all natural numbers are integers. This is true. All integers are rational numbers. That is, can you write all integers as a fraction? Yes, this is also true. All whole numbers are natural numbers. Now, all whole numbers are natural numbers. Is this true or false? If you can think of one exception here, it has to be false because it says all whole numbers. And in fact, it's false. And I'm going to say counterexample. A counterexample is an example where it disproves that statement. Counterexample. Consider 0. 0 is a whole number, but it is not a natural number. All irrational numbers are roots. Well, that's a very good question. What is roots? Well, we think square roots and cube roots and fourth roots and fifth roots, but I'm going to say this is false. Now, the counterexample that I'm going to give, pi. 5. Some rational numbers are natural numbers. This is true. Now, if you're looking for an example, so some rational numbers are natural numbers, consider 7 over 1. This would be a rational number that it would be better known as 7. So 7 over 1, is a natural number and is also rational. 1/2 of a rational number, but not an integer. What? 1/2, okay, wait, I misread that. 1/2 is a rational number, but not an integer. So 1/2, I'm just going to write 1/2 right there. So 1/2 is a rational number. True. It is not an integer. True. So this statement is entirely true. 0 is a natural number. Ugh. That is false, right? 0 is not a natural number, but it is a whole number. So this is actually false. All repeating decimals are irrational numbers. Again, false. I'm going to give you a repeating decimal, 0.3 repeating. We could write this as 1/3. So that would be a repeating decimal, but it is rational. All terminating decimals are rational. This is a true statement. All irrational numbers are a part of the real number system. And in fact, this is true because real numbers, as we saw earlier, real numbers are anything that are rational and irrational. But if we take a look at our picture, the real number set sort of includes everything that is wrapped up in that all we know about numbers. If you're particularly keen, you can give me the counterexample to this if you watch many videos about imaginary numbers, because imaginary are not part of the real number set. Anyways, I'll conclude the video.